Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. I am Desire, and today we have got Aaryan, who has completed the course Linux Basics for Robotics. So what we'll do is we'll first see a demonstration of his code base on a real robot, and as we progress we'll also get to review his code base to understand what he did, and towards the end we'll get to ask him a couple of questions. So I will now hand over the platform to him so we can begin. He can begin his presentation. All right. Whenever you're ready, Aaryan.
But, okay. Hello. So first we will start our Python script, which will publish the uh, board data to the framework. It is started. So now we will start our base script.
Okay.
Now our base script is running.
Okay.
It is whole following. So first it will find the positions and means it will detect wall and maintain a particular distance,
Mm-hmm.
and it will follow the wall.
Okay.
So uh, that you can see, first it has detected distance left and front,
Mm-hmm.
and then it is setting parameters. Parameters are the velocity components, means linear and angular velocity,
Okay.
and then it will run in infinite loop for a continuous real-time operation.
All right.
So as you can see, it is following the ball by maintaining a zero point 0.3 meter distance from the ball from the left side.
All right.
As you can see, novel found it is finding the ball and to maintain the particular threshold distance from the ball.
Mm-hmm. All right. Can you now switch on um to a simulation version of of your code base? Can you run it in simulation now, since we've seen it working on the real robot?
Okay. simulation is started.
Mm-hmm.
So now we'll run our code again.
All right.
Um, I think I need to run my Python code also again
Mm-hmm.
because it is not finding the node.
All right. All right.
Now Python code is started, so node is created.
Mm-hmm.
So now we can run the code. Still not found it. Mm. Minute. I am reopening the terminal.
Okay.
So we cannot get same errors again and again. Now simulation is started. We will run our code. But we will run the Python code and create the node
Okay.
so we can interact with our base script. We are getting some errors, so I think we should restart the
Did you try sourcing your
session.
installation directory?
WhatsApp.
Did you source your installation directory? Did you do source install setup.bash?
Sourcing I have did in means it was running Python code. Python code run without sourcing, I think.
Yeah.
I did same in a last project.
Okay. Yeah, yeah. It's ideally it's supposed to work. All right. Anyway, let's do some review on the code that you have used on the real robot. Right. It's the exact same code that you want to run in simulation. So, let's go through that for now, and you explain in detail what you did, and
Okay. First, we have initialized the base to the system to use. We have set the system with this to use base from the user slash bin.
Mm-hmm.
Then we have created a get left distance
All right.
function,
All right.
which
Just
is
just hang on. Can you explain in detail what objective you're trying to accomplish by this code base, right? Because you started explaining functions, but we want to know what was the goal of writing this code. What was it supposed to achieve on the real robot or in simulation, right? Can you make us understand that first, and
uh,
then you can get into explaining what each function does.
the objective was to follow the wall uh, with interacting the ROS2 nodes, and we have used base script for the automation.
Mm.
So can I start with functions now?
You can go ahead. Yes.
So with this function, we are interacting with node robot interface, which is created with our Python code, which we run first. Uh, with this, uh, we are getting the value of the uh, left distance from the LiDAR, and we have used this uh, because this will give us the output as something like end distance 5.4. First will first first this will be the something words which we don't require. So at the fourth position, our distance value will be. So we are directly getting the distance value. So here we have used this to extract the uh, fourth word or the directly distance. Same we have did in this function, which is made to get front distance from the robot. And these functions are used to set the speed. You can see almost these are similar, but here we have used set instead of get. Set is used to set the parameters um, in this node, and this will be the value which we want to set. Uh, this we will pass further in a code when we require to set the speed. As you can see here, our main loop is starting. First, we will print running wall follow mode. Echo is used to print, and the sleep command is used to give a delay. And here we have used while to loop. It, it will run our code in infinite loop for a continuous operation and real-time control. So first, we have defined a variable left, and with dollar we have uh, wrote our function. So this dollar and brackets are used to uh, run this function and get the value. So this will run the this function and give that value to the left variable. And same we have did in the front variable. And then we will print the values with using echo. Then our main logic of the ball following is starting from here. If condition first, uh, we have used if and else conditions, and here we have loaded our basic calculator library. So we can perform arithmetic operations like comparing this. We cannot directly compare the in floating values in bash script. So for that, we need to load BC library, which is basic calculator. And to load that, we have used uh, like L. First, it will compare the left left distance value from the threshold 0.4, and then it will go for the another condition statement like it will detect whether the object or anything is in front of it. So it will detect with a 0.3 meter threshold, and when obstacle is detected, it will set the speed parameters to 0 and turn to the right. So here we have defined a delay of 1.5 second
Mm-hmm.
because to turn the robot, because if we are directly jumping from the setting angular speed 0.3 to 0.0, it will run instantly and the robot will not get a time to move or rotate.
Mm-hmm.
So it was the logic, and if the obstacle is not detected in the front, the robot will set the angular velocity to 0, 0 to not rotate and move linearly by speed of 0.1.
Mm-hmm. Okay.
And then again, we have give a delay of 1.5 second. So robot can get enough time to move ahead. Um, it was all about our logic and code.
All right. All right. Can you please show me exactly where you do your distance tracking? Do you do any of that? Um, and just in general, can you explain the purposes of the different Python scripts that you make use of when you run your bash code, right? Can you take me through the what each of those Python scripts does?
This one.
Yes. Just a rundown. Don't try to describe the code in detail. I just want to find out from you what do you understand from how you use that script. What do you understand in terms of what it does exactly?
Our this script will create a ROS2 node and publish the parameters like distance and odometry
Mm-hmm.
to the ROS framework,
Mm-hmm.
and node is created. Then this our shell script, this script will interact with that ROS2 node
Mm-hmm.
and manipulate the parameters like speed
Mm-hmm. Okay. All
when
right.
we want to move or when we want to stop.
Okay. All right. All right. And the other thing I wanted to ask you about is moving away from this Python script, right? Can you give me some of the, or what is the main objective of having bash scripts or creating bash scripts besides doing robot control the way we have been doing, right? There is a bigger picture here. What is that purpose?
Main purpose of the new script is automation. We don't need to type commands in a cell again and again.
Okay.
If task is specific, so we can make a base script, so we can run directly base scripts. We don't need to type every command, each and every command again and again.
Mm-hmm. All right, all right. Okay, so the other question I have is, let's assume that you have got your CPU. You realize that your machine has got an overload, whether you're running it on the cloud or you're running it locally, right? how best can you check system processes in the command line, right? What command can you use to check system processes?
System processes we can use with shell command ps.
Okay, ps, there is some flag. Okay, ps, I would say ps fa, ps folks, right? You could use that flag, and you can also
PS
get,
box.
yes. And there has to be another one that you also can get a table about system processes. Which one is that?
Uh, uh,
It gives very
I don't
detailed
know about another.
information. I think the h top. Okay, that's the one.
Um,
If you remember that, at the very end of your course, you do a very detailed look on that one as well. All right. Then,
it was covered in code, but I forgot.
yeah, okay. Then the other one I wanted to ask you about is you do a lot of working with console output, right? How best, what command can you use to do filtering if you want to filter your console output?
Grep.
Okay, all right, that's good. Thank you. Let me see if I still have some more questions for you. Can you try running your Gazebo sim again so we can see what's or just refresh your whole ROS check?
Can I restart?
Yes, yes.
It started.
Okay, all right. So let's wait for it to complete.
Okay.
Can you enlarge that a little bit? The yes, that map, yes. Can you explain to me um, why it stopped, or why does it have to keep on setting parameters? Just from what you did, can you take us through that?
But this is setting the parameters.
Yes. Is it control stop, control stop? What's going on there?
Yes, it is like control and stop. Means it will set the parameters uh, like linear velocity to some value.
Mm-hmm.
So it move, move, and then with a little bit it will run again uh, 0 0 speed to stop.
Mm-hmm.
Then it will again go to a position, and then uh, it will uh, again set the parameters like whether to go a straight, rotate,
Okay.
something
Okay.
like this.
So it was your way of trying to keep it safe, to do it in
Yes.
bits and pieces like that.
And taking a particular distance from the ball.
Okay. All right. Did you try any other
Mm.
form, or did you experience any form of drift that led you to having to implement it this way?
But
Did you had you implemented it in any other way other than this way? How did you get to implement it like this in a piecewise format? Did you try other methods? That's
uh,
what I'm simply trying to say to find.
I did in a Python, but in a base scripting, I have did this one only.
Okay. All right. All right. All right. As we wait for it to finish execution or to complete its loop, I have one more question I'd like to ask you. So you know that for you to execute or to give files a permission to be able to execute, they have to be given permission somehow, right? It's a repetition of words. Sorry about that, but I'd like to find out from you, how do you do that in the terminal?
Um, like giving permission of read, write, and execute.
Yes, or just to allow your files to execute. Because I remember when you list your contents directory, right, in your SRC folder, you find that other files are green and others are white, right, which means the green ones have got permissions to execute. How do you give them that permission?
Mm. Should I write only code or I can give?
Yeah, sure, whichever way you prefer. Yes.
I think um, I can show you. Uh, this this files we have execution
Yes,
rights.
they have
So
execution permission. Yes. So I want to know, how did you give them
yes,
execution permission?
okay. I am showing. I am giving execution permission to the init.py file
All right.
using
All right.
ch mode, and for giving a permission of execution, we can use 7,
Mm-hmm.
7, 7,
Mm-hmm.
and we can write the name of the file.
All right.
So you can see
Now it's
we
good.
have given the execution.
All right.
Mm.
Which other way
Uh,
can you do it? There has to be another shorter one other than 777.
plus X.
Yeah. Okay, that's good.
Mm.
All right. Thank you very much, Aryan, for your presentation. It seems your robot is struggling a little bit. I can see it's going back in the demo there, but it's fine. I think we can end it here. So you just hang on. We'll wrap it up and then we'll finish our conversation on Zoom. Okay. All right. Alright, everyone, so this was Aryan's presentation, and I would like to encourage all those of you who would like to try the courses we offer certification on to do the projects. Come do your presentation, and then you will receive your certification on the basis of your presentation. Alright, so until next time.